From Gooseberry Falls State Park, we now move up the shore just a couple of miles to the Split Rock Lighthouse to talk about arrays. Today we're going to discuss the need for arrays as we log on to Janus and do a little programming. So, I'm in Janus, and I'm going to open up a program I've already written here. And let's imagine that the following scenario has happened. Your roommate or friend or your boyfriend or girlfriend has decided that they're taking a chemistry class, and that because you are taking a computer science class, you might be just the person to solve their problem. And here it is. They have to run an experiment 5 times and generate 5 different numbers, and then compute the average. No big deal. Can you write a program that will just compute the average for me if I enter 5 numbers? Sure, piece of cake. You sit down and you do it something like what you see here. Your main program declares a few variables here, num1, num2, num3, num4, num5. That'll store the 5 numbers. You want to add up a sum, then you can divide that by 5 and you'll get the average. You ask the user for 5 numbers, you read them in, you add them up, and then you print the output. And the output here is a couple things. First off, your friend wants to see the data values to guarantee you got them in correctly, so you print those out, and then you print out the sum, and then you print out the average. No big deal. So let's test this. And run it. Please enter 5 numbers. Okay. There's my 5 numbers. It apparently got them correctly and printed out the sum and the average, and away we go. So this looks great. It looks like we've got a workable program, and you give this to your friend, they go off and they use it, and that's the end of the story. Until next week when they come back to you and say, oh, okay, things have changed a little bit. I wonder if you could just make a modification to your program. Instead of, well, we're doing 5 numbers, but we're combining groups now. So each group that comes together is going to have 5 numbers. And can you modify this program so that it works with 10 numbers? And okay, we can kind of do that. I haven't made that change here, but I can. So it's got 10 numbers now. Okay. I guess I need some more variables. So I'll type in some more variables. There. Okay, now we got those 10. And let's see, I got to change this line here because it says enter 5 numbers, and you want 10 now. And then you're going to read in, oh boy, you're going to read in 10 numbers. Okay. That's a big long monster line, but got it all in. And and then I'm going to add up 10 numbers too, I guess. So plus num6 plus num7 plus num8 plus num9 plus num10. Okay. Oh, and then we got to print these things out. So I'm just going to do a copy paste here, streamline this, and I'll change some of these things. Num6, num7, num8, num9, 10. And then we're going to get the average, we get the sum, we've got to divide by 10. Okay, fine. That took a little bit of doing. It's kind of a pain to have to type in a whole bunch more variables, but at least, we can do it in a reasonable amount of time. It should still work, unless I screwed up when I typed something in here. Okay, and now we can type 10 numbers. Let's see. I don't know, whatever. And there they are. It prints all the numbers, prints the sum, prints the average. Things look pretty good. Okay. You give it back to your friend, everything's cool. Then the next week, your friend comes back and says, oh, this is great. Thank you for doing this. This worked really well. We combined the two groups and around our table, and we got the 10 numbers, and everything is cool. I wonder if you can make another modification for us this week, because what we need to do now is we're combining the tables. Each table has like 2 groups, and there's like 8 tables. And so we need to do the average of all those values. So can you change that? And then you say, okay, wait a minute, 8 groups, or 8 tables, 2 groups per table, so that's 16 times 5, that's like 80 values. And now you realize there's no way. There's no way. I'm not going to get into my program again and modify this so it's got 80 variables. I mean, it's ridiculous. And for all I know, the next week they're going to come back and say, oh, now we're doing it, we're combining the classes, and now we've got 200 variables. We can't do this. The fact is we made a big mistake early on and we didn't realize it. When we were asked to solve the problem for 5 numbers, we wrote a program that solved the problem for 5 numbers. We addressed only one specific case, a specific case of the problem. We didn't address the general case of the problem. Okay? The general problem is write a program to add up a bunch of numbers and give me the sum. We custom built it for 5, and we shouldn't have. We should make it as general as possible. So let's get out of here and see if we can rewrite this program so it's more general, so it will work no matter how many values they've got. And now I've got one. I've got a program now that uses a while loop. We ask them to, here I guess we're assuming these are positive numbers or 0 that they're entering. Give us some data. So we read in a number. As long as the number is greater than or equal to 0, we add it to the sum. And then we have a counter that's keeping track of the count, adding 1 each time. That count was declared up here. Probably should be an integer, not a double. Okay? But there it is. We set the count to 0, and every time we go through the loop, we add 1 to the counter. And then we ask for the next value, and if that value is good, we process it, add it to the sum, and then add 1 to our counter. And we do this over and over again. Read a number, add to the sum, read a number, add to the, and it doesn't matter how many values they've got. They've got 5, they've got 10, they've got 80, they've got 240. We don't care. We don't care. They're just going to type numbers in until they're finished. When they type a negative number, we're done. And at that point, we'll do the sum and we'll do the average. Okay, let's get out and compile this one. And run it. Okay, so I'm just going to type some numbers in here. That's good enough. I can type as many as I want. When I finally type a negative value, the loop is over, and it tells me the sum was 237, the average is 39.5, and so on. So this is a much better solution. It's a generalizable solution. It scales up. It handles all the situations where they want to type in 5 numbers or 10 or however many they want. We can handle it. Only one small problem. Hardly worth mentioning. But those first 2 programs that were really clunky, that just awful solutions could still do something that this program can't. Right? See if you can identify what it is that those two programs could do that this one can't do. And you'll see, as strong as this program is in addressing the general problem, the one thing this program can't do is print out the data values after you've entered them. And why? And the reason for that is because we destroy them. Every time we do a cin, we only have one place to store data. It's called num. And so the new data value comes in and replaces the old one. So we're kind of burning our bridges behind us. We don't have the data after this loop is over to do anything with. The other two programs had the data still. So we could check it and we could do other things with it if we wanted to. But this one doesn't. So this is a very strong solution from the standpoint of addressing the generalizable demands of the program, but it's not a strong solution in terms of keeping the data around. The control structure is great, but the data structure is very imperfect. And that's why this week, as we discuss data structures, we're looking for something that gives us not just control within a program, but also gives us the data and allows us to store it. And so now let's look at one more solution. This one uses arrays. Here you can see I declared an array called num. It will store 100 doubles. We're going to add them up and get a sum. So I set the sum to 0. We're going to count how many there are, but we're going to use a loop control variable to do that, I. It just makes for less typing down the road. So I'll set I to 0, and then I'll say, okay, start entering numbers. And now we'll read them into the array num into location I. We can store up to 100 numbers. So they can enter up to 100 if they want. Now if the person comes to you and says, oh, I need to store 240 numbers, that's no problem. Hang on a second here. Let me just boost the size of the array. I'll store up to 500 numbers now. So whatever you want to, go crazy. And our array will be used to read data in one by one by one by one until they say it's time to stop. And when they do, then I has been increasing each time, and so whatever I is will be the count. And now we're good to go. We can compute the sum, we can compute the average, and everything is set. So it's a very strong program. It uses arrays to do the processing, and all that's great. Let's get out, let's save it, Control X, let's compile it. Let's run it, type in a bunch of values, negative value to stop, okay, and there we are. Oh, but wait a minute, we haven't addressed the one concern that we had from the previous version of the problem. How do we, after we've read in the data, how do we display the data so that the user can verify we got it correctly? Let's go back in here and do that. All the data went into the num array. After the loop is over, we should be able to access all that data, and we will. And I'm going to use a for loop at this time. We'll start I at 0 and run it up to whatever the largest value is, so count number of times. And for every element in the array, we'll just print it out. Okay, so that's cool. We're using a for loop now to march through the array and print everything out. And you can imagine that since we have all the data, we could use for loops to go through the array and do anything we wanted to. If we want to, at this point, instead of adding things up, compute a standard deviation, or sort them in order from low to high, or determine the median, or whatever we want to do, we can do that now because we've got the data in the program. But this is a minor demonstration of that. We should be able to print out all of our data now just using a for loop to go down our array. Control X to get out. And let's compile this. And let's run it. Enter your data values. And let's do the -9. And you can see it calculated the sum, it calculated the average, and it printed out all the values. We've got the whole package here. And that's why arrays are important, because they allow us to read in lots of data and preserve that data in our program so we can use it later to do whatever we want. So super powerful tools. That's what we're working on this week. Be sure you look at the videos, and you'll see they address how to pass arrays into functions and how to do many other things with arrays, read from data files, and so on. So important week, and stay tuned, we'll have more videos. Thanks for watching.